Hello students, good morning everyone. Hope you are doing good. Welcome to today's physics class. Today I am going to teach the second unit, current electricity. So what is the first unit? Electrostatics. Electrostatics means study of charges at rest. So in the first unit we have discussed about the properties of charges when it is at rest. But in reality the charges are not at rest, the charges are moving. So the motion of flow of electric charges is current electricity. The motion of charges is current electricity. So what is current electricity? It is the study of flow of electric charges. Study of flow of electric charges. The scientist Alessandro Volta, who invented the electric battery, which produces the first study of flow of electric current. So without electricity we can't able to operate any machines, communication systems will be collapsed, home appliances will be collapsed. So the modern world heavily depends upon this current electricity. So we have to understand about this current electricity. So in this unit we are going to learn about the current, resistance and some related phenomena. So electric current. First, matter. Matter is made up of atoms. Atom consists of protons, neutrons and electrons. You all know this. So electrons are revolving around the nucleus. Nucleus consists of protons and neutrons, electrons revolving around the nucleus. So when you consider the atom, one or two electrons may loosely bound to the nucleus. It is very freely moving. That electrons are called, those electrons are called free electrons. Free electrons. The electrons which are loosely bound to the atom is known as free electrons. When the substance contains abundance of these free electrons, we can call it as conductors. The substance contains abundance of free electrons, call it as conductors. Okay. Now, in the conductors, the free electrons are randomly moving. Random means here and there it is moving. So there is no net transfer of charges from one end of the conductor to other end. Randomly moving. So there is no net transfer of charges from one end of the conductor to the other end. So there is no current. But when you apply the potential difference, across the conductor, these free electrons will be drifted towards one side with a particular velocity. So now the charges are moving slowly in one direction. The flow of charges constitutes electric current. Okay. Now we are going to see what is meant by electric current. Current is defined as the rate of flow of charges through a given cross-sectional area. Rate of flow of charges through a given cross-sectional area. Consider this is a cross-sectional area. This is the charges It is crossing across this area and it is coming on. So now the movement of these charges constitute current. Movement of these charges constitute current. So rate of flow of charges through a given cross-sectional area is electric current. So how can you define the electric current? Electric current is defined as the rate of flow of charges through a given cross-sectional area in a particular time. That is known as electric current. Let us see the expression. If Q be the net charges passing through a given cross-sectional area in time t, then we can write the expression for current as I is equal to Q by T. I is equal to Q by T. So rate of flow of charges. But this current is not constant. So we can write a average current. Average current. Average current is delta Q by delta T. Delta Q by delta T. That means delta Q is the amount of charges passing through a particular cross-sectional area in a time interval delta T. Otherwise, instantaneous value of current. Instantaneous value of current can be written as limit t tends to 0. Delta Q by delta T, that is equal to dQ by dt. This is about current. What is the SI unit of current? SI unit of current is ampere. SI unit of current is ampere. And current is a scalar quantity. Current is a scalar quantity. Now, when 1 coulomb of charge is passing through a cross-sectional area in 1 second, the current produced will be 1 ampere. So I is equal to Q by T. This is the definition of current. From this we can derive a unit. That is, unit of current is ampere. 1 ampere current is defined as the 1 coulomb of charge passing through a given cross-sectional area in 1 second. This is about electric current. So current is defined as the rate of flow of charges. Rate of flow of charges. If Q amount of charge is passing through a given cross-sectional area at any time t, then I is equal to Q by T. Or else we get the average current is I is equal to delta Q by delta T. The SI unit of current is ampere. 1 ampere is defined as when 1 coulomb of charge is passing through a perpendicular cross-sectional area in 1 second, the current produces 1 ampere. Now, conventional current. Conventional current. That is explaining about the direction of the current. Suppose consider this is a circuit. This is the resistance or electric bulb. So what is the direction of current? So this is the direction of current. We know that electron sound always flows from negative to positive direction. Negative terminal to positive terminal. And the current flows in the opposite direction, that is positive to negative. So by convention, the direction of the current is from positive terminal to negative terminal. The electrons flow from negative to positive. Electric current flows from opposite direction of the electron, that is positive to negative. This is about conventional current. You can ask, you said that it is a scalar quantity, then we are telling about the direction. Of course, current is a scalar quantity. But this current has direction. Even though it has direction, it does not satisfy some of the properties of vectors. The 11th standard you have learned the vector properties, especially triangle law of addition, parallelogram law of addition and all. That kind of properties cannot be satisfied with this current. So even though the current has proper direction, we will consider as a scalar quantity. Okay? Next, we are going to learn about drift velocity. Drift velocity. What is the drift velocity? Consider a conductor. It consists of charges. When there is no electric field is applied, the charges are in random motion. If you apply the electric field, the charges will be aligned in one direction. Obviously, in the classroom, when there is no teacher, you all will be in the random positions. You will be talking and you will be changing your places. When the teacher enters the class, you all will be aligning in the particular places. Similarly, here also, in the conductor, whenever there is no electric field, the electrons are in random motion. But when the electric field is applied, these free electrons get accelerated. There is force exerted. The force is used to accelerate the free electrons. So the free electrons will be aligning. First it has a zigzag path of motion and here and there it will be collided. Then slowly it will be arranging in one direction. So with the application of electric field, the electrons are drifted towards the positive terminal of the battery. So this electrons travels with a particular velocity. That velocity is known as drift velocity. So whenever there is no electric field, there will be no current. If you apply the electric field, if you set up the potential difference across the conductor, it experiences the electric force. This force accelerates the electrons. Now these electrons drifted towards the positive terminal. Drifted towards one direction, that is the positive terminal of the battery. So what do you mean by drift velocity? Drift velocity is the velocity acquired by the electrons inside the conductor when it is subjected to an electric field. What is drift velocity? Drift velocity is the average velocity acquired by the electrons inside the conductor when it is subjected to an electric field. Let us see the expression for this drift velocity. Consider the symbol of drift velocity is Vd. Here, consider the A be the acceleration, A be the Vd be the drift velocity, A be the acceleration, and tau, this is known as mean free time. This is known as mean free time. It is the average time between the two successive collisions of the electrons. Average time between the two successive collisions of the electrons. So Vd is the drift velocity, A is the acceleration, tau is the mean free time. Now let us see the expression of Vd. We know that acceleration is equal to velocity divided by time. From this, what is velocity? Velocity is equal to acceleration into time. Acceleration into time. So here Vd is the velocity, acceleration is a, and the time is tau. So Vd is equal to a into tau. We have to substitute the value of a. How can we substitute? Consider the force formula. According to Newton's law, force can be written as mass into acceleration. From this, acceleration can be written as a is equal to F by m. A is equal to F by m. And substitute the value of force. Here electric field is applied. So we can write electric force. Electric force can be written as E into E. This you have learned in the first chapter. The electric field and electric force relation is F is equal to E into E divided by m. So A is equal to E by m. Okay? And substitute in this equation, Vd is equal to E by m into tau. Here we are putting the sign minus because the electrons are drifted towards the positive terminal. That means it is aligning opposite the direction of the electric field. It is aligning opposite the direction of the electric field. So we can substitute the negative sign. So Vd is equal to minus E by m into tau. Minus E by m into tau. So this is about drift velocity. What is the unit of drift velocity? Nothing but meter per second. Meter per second. So what is drift velocity? Drift velocity is the velocity acquired by the free electrons inside the conductors which is subjected to an electric field. So it can be derived from Vd is equal to acceleration into mean free time. So from this, substituting the value of A, that is force is equal to ma, A is equal to F by m, force is electric force, so E by m. So we can write Vd is equal to minus E by m into tau. The minus sign is the electrons are drifted towards a positive terminal, but it is subjected to an electric field and it is aligned opposite to the direction of the electric field. Okay, this can be rewritten as Vd is equal to minus E tau by m into E. We are rearranging and writing. So this can be written as Vd is equal to mu into E. Minus mu, when you are taking the mark, we can write minus modulus mu into E. What is meant by mu? Mu is known as mobility. Mu is known as mobility. So mobility, mu can be defined as mu is equal to Vd by E. Mu is equal to Vd by E. So mu is mobility. Mobility is known as drift velocity acquired per unit electric field. Drift velocity acquired per unit electric field. So drift velocity Vd is equal to minus E by m into tau. We are rearranging and writing Vd is equal to minus E tau by m into E. This term can be written as mu into E. Mu represents mobility. Mu represents mobility, or we can write mobility is equal to Vd by E, that is drift velocity acquired per unit electric field. Okay. Now here Vd is a vector quantity, so put an arrow here, Vd velocity, and E is a vector quantity, an arrow here. What is the unit of mobility? What is the unit of mobility? Meter square, volt power minus 1, second power minus 1. How it comes? The unit of velocity is meter per second. and the unit of electric field is volt per meter. Volt per meter. So how can we write this meter will go in the numerator. So meter square, this volt raised to minus, volt raised to minus 1, second raised to minus 1. So this is about mobility. So we have learned about the drift velocity and mobility. Distinguish between drift velocity and mobility. The drift velocity is of the order of 10 power minus 4 meter per second. 10 power minus 4 meter per second. I hope you understood the concept of drift velocity and mobility. It's a very important question. In your book, example 2.2, you can solve at home. That is, if an electric field of magnitude 570 Newton per coulomb is applied on the copper wire, find the acceleration experienced by electron. So, electric field charge and mass is given. From that, you can calculate the value of acceleration. Okay. The problem is solved in your book. Learn from the book and try it in the note. The next topic is microscopic model of current. So far we have discussed about current and drift velocity and mobility. Now let us see the microscopic model of current. So consider a conductor. Let A be the area of cross section of the conductor. Here we are considering the particular length element dx. This is the distance dx. Okay. Here the conductor is applied by means of the conductor is connected by means of a battery. The potential difference is set up across this conductor. So what will happen? When there is no electric field, there will be no current. When the electric field is applied, the electrons are drifted towards to positive terminal. So here we can consider this electrons are drifted towards this direction. Okay, the particular velocity Vd. The particular velocity Vd. So this, with this distance, we are considering the flow of electrons. Let A be the area of cross section of the conductor and dx be the distance we have taken. Now from this, the dx distance can be given as Vd into dt. How can we write? The velocity can be written as rate of change of displacement. So we can write dx by dt. From this, dx is equal to what? Vd into dt. Dx is equal to Vd into dt. E be the electric field. Now, how many number of electrons available in this volume element? Okay, number of electrons available in this volume element. That is the distance dx. In the distance dx, how many number of electrons are available? How can we write? Volume into number of electrons per unit volume. Number of electrons per unit volume. So what is volume? Volume is area into height. So A is the area of cross section. Your height is nothing but the distance dx. So we can write A into dx into small n. So Small n be the number of free electrons, number of electrons per unit volume. Now, substitute the value of dx from this relation. A into, what is dx? Bd into bt. Into n. So, number of electrons in the volume element dx is equal to A, Bd, dt into n. Now, the charge of an electron is E. Then, total charge of these electrons. Total charge of these electrons. Multiplying the number with this charge. So, total charge available in the volume element can be written as a single charge E into total number. So, this is the total charge. That is N A B D into B T. Now, what is the current? Current is equal to rate of flow of charges. That means dq by dt. So, we can write NAEBD into dt by d. So, dt get cancelled. What we will get? I is equal to NAEBD. So, this is the microscopic model of current. Listen here, consider a conductor having area of cross section A. Here we are considering the particular length element dx. An electric field is set up across this conductor. So, because of the application of electric field, the electrons will be drifted towards the one end with the drift velocity v. Let us see the Vd with the drift velocity. So, velocity can be written as dx by dt. That is the flow of charges in time interval dt. In this volume element, the flow of charges in time interval dt. So, Vd is equal to dx by dt, dx is equal to Vd into dt. Now, number of electrons available in this volume element is equal to volume into number of electrons per unit volume. So, what is the volume? Area into height. That means here the area of cross section is A, height is nothing but this distance. So, A into dx into n, where n be the number of electrons per unit volume. That is equal to A, substituting the value of dx from here, we can write A Vd into dt into n. Now, charge of an electron is E. So, what is the total charge of electrons? Multiplying this charge with the total number. Can write total charge is equal to E into A Vd dt into n. So, we can write N A E Vd into dt. What is current? I is equal to dq by dt. That is equal to Na EVD dt by dt. So, dt get cancelled. We will be getting I is equal to Na EVD. So, this is known as the microscopic model of current. This is the microscopic model of current. I is equal to NaEVD. Next, one more concept, current density. Current density, it is denoted by J, that is equal to current per area. Current per area. So, what is current? NaEVD. So, we can write NaEVD by A. So, A get cancelled, J is equal to NeVD. NeVD. Current density is a vector quantity. Current density is a vector quantity. If you substitute the value of Vd, what is Vd? Minus E by m into tau. So, we will get minus n E square E by m into tau. This is current density. Here the current density we are taking the positive value because the current density and the electric field are in the same direction. The drifted electron flow and electric field are in the opposite direction, but the current density and electric field are in the same direction. So we can take the magnitude as J is equal to N E square tau by M into E. Now this term can be written as sigma. So J is equal to sigma into E. J is equal to sigma into E is a vector quantity. What is meant by sigma? Sigma is known as the conductivity. Sigma is known as the conductivity of the material. So we can write sigma is equal to N E square tau by M. What is current density? Current per unit area. Current density is defined as the current per unit area, that is denoted by J. J is equal to I by A. Substitute the values, we will get N E VB. Substituting the value of VD, we will get minus N E square E by M into tau. So this negative sign you can negate because the current density and electric field are in the same direction. So we can take the magnitude N E square tau by M into E. That can be written as J is equal to sigma into E. The sigma is known as the conductivity of the material. And sigma can be written as N E square tau by M. What is the unit of current density? Ampere per meter square. What is the unit of current density? Ampere per meter square. Okay students, today we have discussed about current, defined current and drift velocity, mobility, then microscopic model of electric current. This is very important question. So try to learn the book back questions. Page number 122. First question, why current is scalar? Distinguish between drift velocity and mobility and microscopic model of current. Thank you.